Another really good example of how dimensional analysis helps us with formulas and equations is the following. Use dimensional analysis to determine how the period of a pendulum depends on mass, length of the pendulum, and acceleration due to gravity. Okay, note that it gives us no other information except for the fact that acceleration due to gravity is given in units of distance per time. Okay, and we are required to take the mass of the pendulum as m, length of the pendulum as l, and acceleration due to gravity as l over t squared. The other thing that it gives us is that the period of a pendulum is how long it takes the pendulum to complete one full swing, starting from one side, going to the other side, and swinging back. And its dimensions are t. Okay, based off of this information, can we use our prior knowledge as well as dimensional analysis to predict or to come up with a relationship between the period of a pendulum and mass and length of the pendulum and so on and so forth? And the answer is yes, absolutely we can. Now here's another really good question, right? So dimensional analysis to determine how the period of a pendulum depends on the mass. What we are going to do is first I'm going to tell you what is a pendulum. A pendulum is a mass attached to a spring. And this is a complete cycle, starting from this side, going all the way over, and coming back. This defines what is a period of a circle. And it says that now take what I've given you, the period of a pendulum is how long it takes to complete one swing. Figure out how it depends on mass, length, and on acceleration due to gravity. Okay, so first things first, what do we know? Mass, he wants us to calculate it in terms of mass. He wants us to calculate in terms of length of the pendulum, so L, and he wants us to compare it to the acceleration due to gravity, which is G, whose units are meters per second squared. Dimensionally, they will be written as L divided by T squared, or L T minus 2. Okay? Now, I'm going to tell you a little trick on how to do these problems. So first of all, on my right-hand side, I need it to have a period, right? And on my left-hand side, I need to have it be the period. On my right-hand side, I need m, which is mass, which is given. I need L, which is another thing that's given, and G, which is another thing that's given. Okay? In other words, what it is saying is find the period. Here's what I'm going to write it in words. Find the period of a pendulum in terms of its mass and length and acceleration due to gravity. Okay, which is G. Ooh, funny looking G. No, just a plain G. Okay? Now, m is the mass, L is the length, and G is given in terms of LT minus 2. Here's a trick. On this side, because this is what our final is, we're not going to do much. So we're just going to put a number 1 here. Okay? For my mass, I want you to put A here. For my length, I want you to put to the power B. And for acceleration due to the gravity, I want you to put a power C. Okay? Basically what I've done is I have put a coefficient to the power A, B, and C for your mass, your length, and your acceleration due to gravity. Okay? Now how is this going to help us? Actually, this is going to be very, very useful. So now we're going to compare coefficients. So compare coefficients, right? So let's start with m. Okay, on this side, if I was to look at it, is there any term that depends on m? Nope, so put 0 equals a. Okay, compare the coefficient for L. 0 equals, here's the trick. Now combine these two together. It is going to be B plus C. Okay? Now compare the coefficients of T. On the left-hand side, I have 1 equals minus 2C. Okay? Do you see it? So I'm just taking all the terms that have t in m together, all the terms that have l together, and all the terms that have m together. This implies my period of the pendulum cannot depend on A. Okay? Now if I was to take this expression, this means that C equals minus a half. Agreed? Which means if I plug this value back into here, C here, I can calculate B is going to be equals to a half. Okay, now we have actual numbers instead of B's and C's. So we're going to take them back and plug them into this long expression here. Now go ahead and write them, and I'm going to rewrite this expression again in terms, instead of calling them A, B's, and C's, now I have a number, I'm going to be able to plug them back in. Okay? So I can rewrite this as 0. I can rewrite B as a half. I can rewrite this C as a minus half. And I can rewrite this C as a minus half. Okay? So my upper expression now reduces down to t to the power 1, which is equals to nothing, because m to the power 0 is nothing. And I have an L a half and an L of minus a half and a T squared. Oh, actually, no squared. Just a T, because 2 gets canceled with 2. Woo. Be careful. Now see what happens. L a half and L a half goes away. What am I left with? T on this side and T on this side, just the way it's supposed to be, right? Now, my original question was, how does the period depend on length and G? Okay, so take this half. What does that mean? That actually means that it is the square root of the number, right? And L as a minus half can go to the bottom. So I'm going to rewrite this again, and I'm going to rewrite them in terms of L a half divided by L a half, right? And T. Okay, now, what did we say the value of G was? It was LT squared. Now, in order to bring us back to the original question that it was asking, what we are going to do is rewrite this expression as length divided by length and T squared square root. Because that's what you do when you have a square root. Now look at this expression very carefully. What does this remind you of? T over L, T squared. I can rewrite that as L over G square root. So this means, dimensionally this is correct, and my final answer shows that the period of the pendulum is proportional to square root of length over acceleration due to gravity. Okay? Now note this thing very carefully here. How did I convert it? Okay? And that's what my final answer is going to be. So do a little bit of a thinking and it will make sense. Okay? Knowing that G is equals to L over T squared. Remember that.